As we can, what is a generator in Python? Well, the core idea of a generator in Python is more or less the core idea of a function in Python, but combined with the idea of an iterable and an iterator. In other words, we may have some function that performs multiple operations, multiple steps, step 1, step 2, and step 3. And there may be some value for taking that structuring, and instead of expressing that structuring just in the form of comments, this is what we do first, this is what we do second, this is what we do third, expressing that structuring in a fashion where we can use it for some purpose. And so if we had some function that took some initial data and it did 3 things, maybe it computes 3 results. Now this isn't altogether too interesting, but it's a simple enough example. Here we compute x plus 1, we compute x plus 2, and we compute one more value, x raised to the 3rd power, and we return all 3 of these. This is what we might call an eager computation, in part because even though we've identified that there are 3 independent steps, we can't run those steps separately. All of them must run to completion before we get a value. But a generator is our way to formulate the idea that actually there's some structuring here. There are in fact 3 steps here, and those steps can be run independently of each other. And in between running each of those steps, maybe we can choose to go do something else. And so if we model this function as a generator, well, the syntax changes a little bit, but our ability to use this changes quite dramatically in terms of our capabilities. In other words, here, the syntax is going to change. First, we have to create a generator instance from this thing, and then we have to step through that generator instance. But what you can see is we can get each one of these values independently. So if it were the case that this is a little bit more interesting than just computing 3 things, well, it may be the case that we might say, only compute the first 2 values, the 3rd value is not necessary, it's just wasted time. Or we could say, compute the first 2 values, then go off and do something else, and then come back and compute the 3rd value. We can break up that one computation into multiple parts. Now, fundamentally, we have this distinction now, and the same sort of indirection between the iterable and the iterator, the idea that the generator here is a description of a computation that's broken down into parts. And the generator instance is why we call it this with an I, not a generator iterator, but a generator instance, is one instance of that computation and where we last left off, i.e. the last step of the computation that we happen to run. It turns out that Python, the interpreter, names everything completely different. So when we see this, we actually typically call this a generator. And when we see this, we typically call that a generator instance. But core Python actually calls this a function that returns a generator. And this is why when we look at the CPython interpreter and we see what it names everything, we typically don't use those because it just gets very, very, very confusing. However, I do want to note that this idea of the generator and the generator instance, well, there's something that is implicitly mutable here. For example, if I have some computation on some data set, and I go through each element of this data set, and I say, okay, I'm going to perform some operation on each element of this data set, maybe square it. And instead of storing up all of those results and then returning them once, I'm going to incrementally yield them. So if this data set happens to be some very, very large non-materialized iterable itself, well, I could say, you know what, I don't really care. Sorry, this should be G. I don't really care to do all of these computations. Maybe I just want to kind of peek at this. I just want to look at the first and second and third computation, and then that's enough for my purposes. Then I might decide, do I want to keep going or not? If this were a function, I'd have no choice. I'd have to run this to completion, which might involve the materialization, the implicit materialization of a return value of the same size of the input data set. Well, when you see this example, I want you to understand that these generators are fundamentally mutable. One of the consequences of them are, if I wanted to peek at the result of this sequence of computational steps and then decide keep going or not, no big deal. I could say if this result is greater than 0, then keep going, otherwise don't. But what I cannot do is I can never rewind this thing. A generator instance is a mutable structure. It is stateful. It represents an ongoing computation. You cannot rewind that thing. You can basically only advance it and take what it gives you back or throw away what it gives you back, but you can't do anything else. And so unlike other iterables that we deal with, like lists, where we can go through them forwards, we can go through them backwards, we can go through them multiple times in a row, generators represent a computation that we can only proceed through in one direction forwards, and where that instance of that computation is a very deeply mutable thing.